On November 14, 1944, at 4:37 hours on Bougainville Island, Staff Sergeant Thomas McKenna, a 23-year-old soldier, found himself in a precarious position. He lay pressed against the volcanic mud of the island, listening intently to the sounds of approaching danger. The noise emanating from the darkness ahead was rhythmic and methodical, the unmistakable sound of Japanese sappers digging, drawing closer to the American defensive line with each passing moment. McKenna held command of a machine gun position situated on the perimeter of the 37th Infantry Division's forward base. His weapon, an M1919 A4 Browning machine gun, sat mounted on its tripod and loaded with standard ball ammunition. A stretch of 200 yards of open ground separated his defensive position from the jungle tree line. Intelligence indicated that Japanese sappers were conducting underground tunneling operations in the area. Over the previous 4 nights, these enemy engineers had successfully breached 3 different sections of the American perimeter, emerging from concealed spider holes to deploy grenades and satchel charges before disappearing back into their subterranean network. The challenge facing McKenna was significant. Standard ball ammunition proved ineffective against an enemy that remained invisible underground. Despite having fired approximately 2,500 rounds into suspected tunnel entrances over the past week, the digging operations had continued unabated. The conventional approach to this threat was simply not working. On this particular night, McKenna reached for a different ammunition container positioned beside his gun emplacement. This can possessed a noticeably different weight and produced a distinct sound when the ammunition belt shifted inside. An armorer had delivered this special ammunition 3 hours earlier, accompanied by minimal instruction: fire in short bursts and report the results. The ammunition belt feeding into the M1919 A4 appeared visually identical to standard issue rounds, yet each individual cartridge weighed 1.7 ounces more than conventional ammunition. McKenna was unaware of the technical reasons for this weight difference, but he was about to discover its combat implications firsthand. The context of Pacific warfare and ammunition limitations. By November 1944, American military forces had been engaged in combat operations across the Pacific theater for 3 full years. During this extended campaign, they had discovered a harsh operational reality. Conventional infantry weapons had not been designed with jungle warfare in mind, and they performed inadequately in this environment. The Japanese military had developed exceptional proficiency in subterranean combat operations. On Bougainville Island alone, American forces had identified and documented over 800 individual tunnel systems. Some of these underground networks extended more than 200 feet below the surface, while others interconnected to form defensive complexes spanning half a mile or more. The standard .30-06 ball ammunition issued to American forces performed exactly as its designers intended when engaging conventional targets. It effectively penetrated human targets and could punch through wooden structures. However, when directed against earth and dense vegetation, it proved nearly useless. A machine gun could expand 500 rounds per minute firing into a jungle tree line and accomplish virtually nothing. The bullets simply disappeared into the layers of leaves, vines, and soil, leaving enemy combatants completely unharmed behind their natural concealment. This problem was not merely anecdotal. It had been carefully quantified by military analysis. Following the Battle of Tarawa in November 1943, weapons analysts conducted detailed assessments and calculated that American forces had expended an average of 45,000 machine gun rounds for every confirmed enemy casualty. During the Battle of Peleliu in September 1944, this already troubling ratio had climbed even higher, reaching 67,000 rounds per confirmed kill. The ammunition functioned as designed, but the targets remained invisible. Japanese tunnel warfare compounded this inefficiency exponentially. Cave systems on various Pacific islands, including Iwo Jima, contained fighting positions reinforced with concrete, coral rock, and steel rails salvaged from destroyed infrastructure. When a standard .30-06 round struck solid rock, it would either fragment or ricochet away. It would not penetrate the barrier, nor would it collapse the tunnel structure. The defender remained completely safe while the attacking force wasted thousands of rounds of ammunition. Alternative weapon systems offered partial solutions but came with significant drawbacks. Flamethrowers proved helpful against fortified positions, but they required operators to approach within 40 yards of the target, and the effective range was actually only 20 to 25 yards. Within this danger zone, a concealed defender armed with a rifle possessed every tactical advantage. Between June 1943 and October 1944, flamethrower operators serving in the Pacific suffered a devastating 92% casualty rate within their first 3 combat engagements. Artillery could collapse tunnel systems, but only with direct hits. Forward observers calling in fire missions frequently could not see the tunnel entrances they were attempting to destroy. They would call strikes based on observed muzzle flashes or suspected locations rather than confirmed targets. A single 105mm howitzer shell cost $32 in 1944 dollars, a substantial sum. Tens of thousands of these expensive rounds were expended in attempts to collapse tunnel systems that standard infantry weapons could not effectively engage. Close-range demolitions offered another option. Bangalore torpedoes worked effectively at close range, but they required infantry soldiers to crawl within feet of enemy positions to emplace them properly. Satchel charges demanded the same suicidally dangerous approach. The tactical situation demanded a better solution. The Pacific Island campaigns conducted between 1943 and 1945 resulted in 41,000 American combat fatalities. Post-war analysis suggested that between 30 and 40% of those casualties occurred within 50 yards of Japanese fortified and concealed positions that conventional small arms could not effectively engage. This represented a massive loss of life directly attributable to the inadequacy of standard infantry weapons against fortified and concealed positions. The development of a solution. The United States Army Ordnance Department recognized the urgent need for innovation. However, they did not have the luxury of time required to design, test, and manufacture entirely new weapon systems from scratch. Instead, they needed to modify existing equipment to perform functions it had not originally been designed to accomplish. The M1919A4 Browning machine gun presented an ideal platform for modification. By mid-1944, American forces had deployed approximately 38,000 of these weapons throughout the Pacific theater. Every infantry company possessed at least 2 of these machine guns. Combat crews knew the weapon intimately, and established supply chains could support it effectively. If ordnance engineers could develop ammunition that made the M1919 effective against fortifications and concealment, they would multiply American firepower dramatically without adding a single new weapon system to the inventory. The solution emerged from an unexpected direction. The innovation came not from infantry officers or machine gun specialists, but from personnel working with anti-aircraft artillery systems. The conceptual foundation originated at Aberdeen Proving Ground in Maryland in March 1944. Captain Richard Hollings, an ordnance officer with an engineering background, had been conducting detailed analysis of anti-aircraft ammunition performance. The M20 Browning .5 caliber machine gun, which was employed in air defense roles, fired several types of specialized ammunition. One of these was the M8 armor-piercing incendiary round, which contained a small explosive charge designed to ignite fuel tanks in enemy aircraft upon impact. Hollings posed a deceptively simple question to his engineering team. Could a similar explosive projectile be scaled down to .30 caliber dimensions? The physics presented significant challenges. A .30 Aux-6 cartridge case possesses an internal volume of approximately 68 grains of water capacity. After accounting for the propellant charge necessary to achieve the standard muzzle velocity of 2,800 feet per second, virtually no space remained for an explosive payload. The bullet itself weighed 150 grains in standard ball configuration. To incorporate explosive content, engineers would need to completely redesign the projectile. The development effort produced the M1 incendiary round, officially designated as cartridge caliber .30 incendiary M1. However, the variant that actually reached combat units in the Pacific during fall 1944 was a modified version that ordnance records referred to as the M1A1 incendiary explosive. The technical specifications and function. The M1A1 projectile represented a fundamental departure from standard ball ammunition design. The complete bullet weighed 162 grains, making it 12 grains heavier than standard issue ammunition. The forward 40% of the projectile consisted of a steel penetrator. Behind this penetrator sat a cavity containing 4.2 grains of a chemical mixture composed of barium nitrate and aluminum powder. At the base of the projectile sat a small percussion cap connected to the penetrator through a spring-loaded firing pin mechanism. The operational mechanism functioned through a carefully engineered sequence. When the bullet struck a target with sufficient force to cause rapid deceleration, such as impacting rock, wood, or packed earth, the inertia of the spring-loaded firing pin drove it forward into the percussion cap. The cap detonated, which in turn ignited the barium-aluminum mixture. The resulting flash produced a temperature exceeding 4,200 degrees Fahrenheit and generated a concussive blast sufficient to shatter the bullet's copper jacket. This explosion sprayed incandescent metal fragments in a 12-inch radius from the point of impact. The practical result transformed each bullet into a miniature grenade. While not powerful enough to kill through blast effects alone, the ammunition proved devastating against concealment and cover. A single round impacting a log would blast a fist-sized hole through it and spray burning metal fragments through the gap into whatever lay beyond. 5 rounds striking a tunnel entrance would collapse loose earth and ignite any flammable materials in the immediate vicinity. Initial testing conducted at Aberdeen during May 1944 yielded promising results. When fired at simulated Japanese bunkers constructed from logs and earth, matching field conditions observed in the Pacific, the M1A1 rounds achieved 340% better penetration compared to standard ball ammunition. More significantly, they created psychological effects that standard ammunition could not match. The visible flash and audible explosion accompanying each impact made suppressive fire genuinely suppressive. Defenders could not simply ignore incoming fire, as each round striking nearby represented both a physical and psychological threat. The first production run, completed in July 1944, yielded 500,000 rounds. Ordnance personnel marked these rounds with a blue tip for visual identification. Standard loading procedure called for mixing them with ball ammunition at a ratio of 1 incendiary explosive round for every 4 ball rounds. This created what became known as a cocktail belt that provided both sustained fire capability and explosive effects. The M1919A4 Browning machine gun required no mechanical modification whatsoever to fire the new ammunition. The rounds possessed dimensions identical to standard .30-06 ammunition and fed through the same belt links without issue. The gun's 24-inch barrel and 1-in-10 rifling twist stabilized them perfectly. Muzzle velocity dropped slightly to 2,750 feet per second due to the heavier projectile weight, but this reduction did not significantly affect accuracy at typical jungle engagement ranges of 50 to 300 yards. Weight represented the only practical concern for combat operations. A standard 250-round belt of ball ammunition weighed 22 pounds. The same belt, loaded with the M1A1 cocktail mix, weighed 26.8 pounds. For machine gun crews already burdened with carrying the 31-pound gun, the 14-pound tripod, spare barrels, and various tools, an additional 4.8 pounds per ammunition belt was noticeable but remained manageable. Initial combat employment. The first combat shipment of M1A1 ammunition reached Bougainville on November 10, 1944. The distribution included 400,000 rounds spread among 12 infantry companies. No formal training program accompanied this issue, nor was any doctrinal guidance provided. Units received only a one-page technical bulletin explaining the round's composition and a critical warning: fire in controlled bursts. Do not sustain fire for more than 100 rounds continuous. Barrel temperatures exceeding 800 degrees may cause premature detonation in chamber. McKenna's unit received an allocation of 1,500 rounds on November 13th, enough to load 6 250-round belts. He loaded the first belt into his weapon at 4:47 hours on November 14th, approximately 30 minutes before the digging sounds resumed. McKenna maintained his watch over the darkness ahead. The time was now 4:46 hours. The scratching sounds that had been audible earlier had ceased 3 minutes prior. This silence indicated that the sappers had moved close to the perimeter, probably within 50 yards of the defensive wire. They had gone silent to listen for American sentries and to time their final approach carefully. His assistant gunner, Private Eddie Kowalski, a 19-year-old soldier from Pennsylvania, crouched beside him with one hand positioned on the spare barrel. This represented standard operating procedure. After firing approximately 200 rounds, the barrel would require changing to prevent overheating. Kowalski had never performed this procedure in actual combat conditions. Neither had McKenna, despite their extensive training. Their unit had rotated to Bougainville 6 weeks earlier. They had fired thousands of practice rounds, but had never engaged in actual combat with the enemy. The critical sound came from approximately 190 yards out. McKenna had paced this distance numerous times during daylight hours to familiarize himself with the terrain. A distinct metallic click indicated that someone had disturbed the warning cans that had been strung in the outer wire as an early detection system. This was not a false alarm triggered by an animal. Japanese sappers were emerging from their tunnels. McKenna pressed his shoulder firmly into the M1919 stock and aligned his sights on the source of the sound. He could see nothing in the darkness, just blackness and the vague outline of the tree line silhouetted against the slightly less black sky. His finger made contact with the trigger. Standard doctrine dictated waiting for a visible target and not wasting ammunition firing blind. He made the decision to squeeze the trigger anyway. The M1919 roared to life at 400 rounds per minute, McKenna's preferred rate of fire, using the adjustable fire rate selector. Every fifth round in the belt was an M1A1 incendiary explosive. The difference in effect became immediate and absolute. The first several standard ball rounds disappeared into the darkness with the normal sharp crack of supersonic bullets cutting through air. Then the first M1A1 round struck something solid 190 yards distant. The explosion manifested as a sharp, bright orange flash that illuminated approximately 15 feet of jungle for a fraction of a second. In that brief instant of illumination, McKenna saw everything: palm fronds, a shattered log, and a human figure diving sideways to evade the incoming fire. The second M1A1 round impacted 2 seconds later, approximately 12 feet to the right of the first impact point. Another flash provided another glimpse of the terrain. McKenna observed a tunnel entrance, circular, approximately 3 feet in diameter and reinforced with wooden planking. He corrected his aim and fired a sustained burst consisting of 20 rounds, 4 of which were M1A1 incendiary explosives. All 4 explosive rounds impacted within 10 feet of the tunnel entrance. The flashes proved blindingly bright in the surrounding darkness. Each explosion illuminated additional detail and revealed more sappers. McKenna counted 5 of them scrambling back toward the tunnel entrance. One soldier failed to reach safety in time. An M1A1 round struck the ground 3 feet from his position. The explosion caught him in the side, and he went down. McKenna observed him clutching his ribs where incandescent metal fragments had penetrated. The wound actually glowed from the burning aluminum embedded in his flesh. Kowalski whispered urgently. McKenna did not respond to his assistant gunner's shock. He shifted his fire to a second suspected tunnel entrance located 40 yards left of the first position. He delivered a 30-round burst, achieving 6 M1A1 impacts. The jungle erupted in sequential orange flashes resembling a string of crackers. Something caught fire, probably the wooden reinforcement planks used in tunnel construction. The flames spread, providing actual illumination of the battlefield. Now McKenna could see clearly. 3 more sappers were running. He tracked them with sustained burst fire. The combination of ball and incendiary rounds proved devastating. Standard bullets forced the enemy soldiers to duck and weave evasively, while incendiary rounds exploded against their cover and eliminated it. All 3 went down within 15 seconds. The time was now 4:51 hours. The engagement had lasted 5 minutes. McKenna had expended 180 rounds of ammunition. The barrel glowed red-hot, visible even in the darkness. Kowalski had the spare barrel ready for immediate exchange, but the engagement had concluded. No further movement was detectable ahead, only flames and silence. The entire perimeter had gone quiet. Other machine gun crews had ceased firing to observe. McKenna's position represented the only one actively engaging, and the visible effects were unlike anything anyone had witnessed from a .30 caliber weapon system. Each impact produced a flash bright enough to be visible from 400 yards away. Lieutenant James Crawford, the platoon commander, reached McKenna's position at 4:58 hours. He had crawled forward through the communication trench. Crawford asked about the nature of ammunition being employed. McKenna explained that it was new ammunition that had been issued the previous day. Crawford observed the burning jungle ahead and questioned whether the tunnels had been collapsed. McKenna indicated uncertainty, noting that assessment would require daylight observation. Damage assessment and tactical implications. The unit waited for dawn in accordance with standard security protocol. Nobody ventured beyond the perimeter wire during darkness, not even to recover bodies or assess damage to enemy positions. At 6:23 hours, first light revealed the extent of the devastation. The primary tunnel entrance that McKenna had targeted showed partial collapse. The wooden reinforcement planks had burned through completely. The earth surrounding the entrance had been churned into loose soil by multiple explosions. Inside the tunnel, visible from the perimeter, lay 2 bodies. Both displayed burn injuries consistent with aluminum incendiary fragmentation effects. The secondary tunnel entrance had collapsed completely. The fire had spread through dry vegetation and ignited the wooden support beams internal to the tunnel structure itself. This structural failure had brought down approximately 15 feet of the tunnel's roof. Scattered across the 200-yard engagement zone were 7 Japanese bodies. All exhibited a combination of gunshot wounds from ball ammunition and severe burn injuries from incendiary explosive rounds. 3 of the bodies contained fragments of burning aluminum embedded so deeply that they had burned through tissue into bone. One soldier's rib cage displayed a hole where an aluminum fragment had penetrated, ignited the surrounding tissue, and burned a cavity 3 inches deep. Crawford ordered a patrol forward at 6:45 hours. The patrol discovered 5 additional bodies in the collapsed tunnels and recovered equipment indicating this had been a sapper unit preparing for a dawn assault on American positions. Among the recovered items were 23 stick grenades, 4 satchel charges, and detailed maps of the American defensive positions showing planned attack routes. The after-action report filed at 1100 hours on November 14th documented the engagement thoroughly. The statistics were remarkable. 180 rounds expended, 12 confirmed enemy casualties, 2 tunnel systems destroyed or rendered inoperable, and 0 American casualties. For comparison, the previous 3 tunnel-clearing engagements on Bougainville had averaged 2,400 rounds expended per confirmed casualty, with an average of 7 American personnel wounded per engagement. Rapid expansion of use. McKenna's unit received 10,000 additional rounds of M1A1 incendiary explosive ammunition on November 16th. Word of the ammunition's effectiveness spread through the 37th Infantry Division within 24 hours. By November 18th, every machine gun crew in the division was requesting the new ammunition. Supply officers worked urgently to redistribute existing stocks, with priority allocation going to units in direct contact with Japanese tunnel systems. The nickname for this ammunition emerged organically from Japanese prisoners and interrogation reports. Multiple captives taken between November 20th and November 30th referred to the new ammunition using the Japanese term Kaminari-U, which translates literally as thunder gun or more colloquially as thunder machine. The name resonated with American forces, who began referring to M1919 machine guns loaded with incendiary explosive belts as thunder guns. Production ramped up dramatically in response to field demand. The Frankfurt Arsenal in Philadelphia, which manufactured the bulk of U.S. small arms ammunition, shifted 15% of its .30-06 production capacity to M1A1 incendiary explosive rounds in December 1944. Monthly output reached 2.3 million rounds by January 1945. Distribution prioritized units engaged in island assault operations. The 1st Marine Division received 400,000 rounds in December 1944 while preparing for the Okinawa campaign. The 3rd Marine Division, operating in the Northern Marianas, received 350,000 rounds. The 7th Infantry Division, preparing for operations in the Philippines, received 280,000 rounds. However, supply never fully matched demand. Even at peak production levels, monthly output of M1A1 rounds represented less than 2% of total .30-06 ammunition manufactured. Commanders were forced to ration the explosive rounds carefully. Standard distribution provided 1,000 rounds per machine gun, with priority given to weapons in defensive positions where those supporting assault operations against fortified positions. The Japanese military attempted to counter the new ammunition through tactical adaptation. Intelligence reports from January 1945 indicated that Japanese engineers were reinforcing tunnel entrances with steel plates salvaged from destroyed vehicles and ships. This countermeasure worked partially. The M1A1 explosive charge lacked sufficient power to penetrate quarter-inch steel plate directly. However, the incendiary effect remained problematic for defenders. Steel plates heated rapidly under sustained fire, and the aluminum fragments would ricochet into tunnel entrances, creating a burning shrapnel effect that made the positions untenable, even when the plates themselves held. The psychological impact on enemy forces proved substantial and measurable. After-action reports from Iwo Jima in February and March 1945 documented a marked increase in Japanese defenders abandoning tunnel positions under machine gun fire. Previously, tunnel defenders would remain in position until killed directly or until flamethrower teams could destroy them. With incendiary explosive ammunition in use, defenders began withdrawing after 30 to 40 rounds impacted near their positions, a dramatic change in defensive behavior. Specific incidents highlighted the ammunition's remarkable effectiveness. On January 15, 1945, during operations on Luzon, Sergeant Michael Duca's machine gun team engaged a Japanese bunker complex at 145 yards range. Using 220 rounds of mixed ball and M1A1 ammunition over a 6-minute engagement, they collapsed 3 connecting tunnels and forced the evacuation of an estimated 30 defenders. Standard ball ammunition had failed to neutralize this same complex during 3 previous assault attempts conducted over 2 weeks. On February 23, 1945, on Iwo Jima, a machine gun team from the 5th Marine Division employed 340 rounds to suppress a cave system on the approaches to Mount Suribachi. The incendiary rounds ignited ammunition stored inside the cave, triggering a secondary explosion that killed 18 defenders and permanently sealed the entrance, a result that would have required extensive demolitions work using conventional methods. On March 29, 1945, during the Okinawa invasion, machine gun fire using M1A1 ammunition engaged Japanese positions in Kakuzu Ridge at ranges exceeding 400 yards. The visible flash from each explosive impact allowed American forward observers to accurately direct artillery fire onto positions that had been effectively invisible when using standard ammunition tracer rounds for target marking. Operational challenges and solutions. The ammunition was not without significant problems. The most serious issue was premature detonation. In approximately 1 out of every 2,500 rounds, the percussion mechanism would malfunction and detonate inside the weapon's barrel. This typically occurred when barrel temperatures exceeded 850 degrees Fahrenheit, a temperature readily achievable after 150 to 200 rounds of sustained fire. Premature detonation would damage the barrel severely, rendering it unusable until replacement. Between December 1944 and June 1945, the Army recorded 426 incidents of barrel damage attributable to premature detonation of M1A1 rounds. The solution proved to be operational rather than technical in nature. Crews learned through experience to limit sustained fire to 80-round bursts, allow 30 seconds of cooling time between bursts, and change barrels every 200 rounds regardless of whether visible heat damage was present. These procedures reduced premature detonation incidents by approximately 70%. Another significant limitation involved storage stability. The M1A1 rounds proved moisture sensitive. The barium-aluminum explosive mixture would degrade when exposed to high humidity for extended periods. Ammunition stored in the Pacific's tropical environment for more than 90 days exhibited a failure rate of 12 to 15%. The rounds would fire normally but would not detonate upon impact. Supply officers learned to rotate stocks aggressively and prioritize issuing older ammunition first to minimize degradation losses. Cost represented an additional constraining factor. Each M1A1 round cost approximately $0.18 to manufacture in 1944, compared to $0.04 for standard ball ammunition. This 4.5-fold cost increase limited how freely the ammunition could be distributed. Budget-conscious supply officers often restricted issue to specific operations rather than allowing general use. By May 1945, approximately 8.7 million M1A1 incendiary explosive rounds had been shipped to the Pacific Theater. Analysis of ammunition expenditure reports suggests that approximately 6.2 million rounds were actually fired in combat. The remaining 2.5 million were either lost to moisture damage, held in reserve for future operations, or still in the supply system when the war ended in August 1945. Technical analysis and combat techniques. The science underlying the M1A1's explosive effect was relatively straightforward, though it required precise engineering to implement successfully. The barium nitrate oxidizer and aluminum fuel created what chemists classify as a thermite-type reaction. Unlike conventional explosives, such as TNT or RDX, which release energy through rapid molecular decomposition, the barium-aluminum mixture released energy through an oxidation-reduction reaction. The barium nitrate provided oxygen atoms, the aluminum provided fuel, and the percussion cap provided the ignition energy necessary to initiate the reaction. The reaction occurred in approximately 0.003 seconds, 3 milliseconds. During this brief interval, temperatures inside the exploding projectile reached 4,200 degrees Fahrenheit. The copper jacket melted instantly. The aluminum, fuel still burning actively, fragmented into particles ranging from 0.5 millimeters to 3 millimeters in diameter. These incandescent particles scattered in a roughly spherical pattern with an effective wounding radius of 6 inches and a visible flash radius of 12 inches. The steel penetrator at the projectile's front was not consumed in the explosion. It continued forward, penetrating an additional 2 to 4 inches beyond the explosion point, depending on target material composition. This meant the round could punch through a log, explode inside the wood itself, and have the steel penetrator continue through the far side, a devastating effect against field fortifications. The effect on fortifications proved dramatic in practice. Wood and earth barriers that would reliably stop standard bullets were breached and destroyed. Gun crews developed sophisticated loading techniques to maximize the ammunition's effectiveness in various tactical situations. While the standard mixing ratio was 1 M1A1 round for every 4 ball rounds, experienced crews varied this proportion based on target type. Against visible enemies occupying light cover, they would increase the proportion of ball ammunition to sustain a higher volume of fire. Against fortifications or concealed positions, they would increase the M1A1 ratio to 1:3 or even 1:2. Belt loading evolved into an art form among experienced crews. Some crews alternated patterns: 5 ball rounds, 1 M1A1, 3 ball rounds, 1 M1A1, to create variable impact effects that kept defenders off balance. Others front-loaded their belt loads with higher M1A1 ratios for the first 50 rounds to achieve immediate psychological effect on enemy forces, then transitioned to standard mixing ratios for sustained fire. The visual signature created by the ammunition generated tactical problems as well as advantages. Each M1A1 impact produced a bright orange flash visible for over 1,000 yards in darkness. This made the firing position extremely obvious to enemy observers. Japanese mortar and artillery crews learned to target these distinctive flash signatures. Machine gun crews firing M1A1 ammunition at night suffered 34% higher counter-battery casualties compared to crews firing standard ammunition.